Today we're going to talk about enthalpy and chemical reactions. When the amount of heat that's involved in a chemical process is calculated, we often have to use a specific heat capacity of a substance in that calculation. And depending on the information that we have available to us, we may need it to be in specific heat, or we may need it to be in something called molar heat capacities. And a molar heat capacity is the amount of heat required to change the temperature of 1 mole of a substance by 1 degree Celsius, and vice versa. So if we have the specific heat capacity of water as 4.18 joules per gram degree Celsius, and we want to know its molar heat capacity, all we need to do is to take this value, joules per, and think about if it's per gram degree Celsius, then the gram and the degree Celsius are on the bottom, right? So if we look at it this way, it's going to be pretty easy to see that if we just do a molar mass conversion factor here, we can end up with moles on the bottom instead of grams. Water's 18.02 grams per mole, so if we multiply by that, then we end up with grams canceling, and we end up with a value of 75.3 joules per mole degrees Celsius, which is the molar heat capacity. We can take a molar heat capacity then and simply change that back to a specific heat capacity by doing the same thing. We'll end up flipping that molar mass conversion factor in order to do it, but we can then end up back with grams on the bottom again. So we can calculate the change in enthalpy for specific amounts of reactants and products in a chemical reaction. For instance, it says here that the equation for the fermentation of glucose to alcohol and carbon dioxide is as follows, and it gives us that equation. And it says the enthalpy change for the reaction is negative 67 kilojoules. Really important that once you know that value and you have a chemical equation, you go ahead and put it in the equation. As soon as it's negative, we know that it is on the right-hand side. Now, negatives don't belong in chemical equations, so plus 67 kilojoules on the right-hand side tells us that we're giving off that much heat. If this were a positive endothermic reaction, if this, for instance, had been positive, we would have added this 67 kilojoules on this side. But of course it's not, so we want to get rid of that before we let this video get too confusing. So this is what we should have at this point. Once we know this, and we've got the heat term in its proper position, it now wants us to calculate the enthalpy change that occurs with the production of 100 grams of ethanol. So we've got, just like any other kind of stoichiometry problem, we know we've got this, 100.0 grams of ethanol. And we want to know what the heat change would be with that much ethanol. So just like any other equation or any other stoichiometry problem, we're going to start with the value that we are given, the known, 100 grams of C2H5OH, our ethanol. We need that to be in moles before we can use any kind of a comparison between the amount of heat given off. And the molar mass of ethanol is 46.08 grams per mole of ethanol. And as we see here, and this is moles of ethanol, remember, and as we can see from the equation, there are 67 kilojoules involved, given off, for every 2 moles of ethanol. So that's our equation. Now remember that value, when you pull it out of there, you might really want to consider making that a negative and putting that negative back in so that you don't make any dumb mistakes when you report the answer, because this ends up being negative 72.7 kilojoules. You could say that it was a negative 72.7 kilojoule change in enthalpy, or you could say that there were 72.7 kilojoules of heat given off. either way, you've got to indicate what direction that heat flow is in because it does not tell you. It just asks for the change. So on the next one, it says to consider the combustion of propane, and it gives us that equation. And it says that if we have 500 grams of propane produces 25.2 kilojoules of energy when it reacts, what's the molar heat of combustion of propane? So we know that 0.500 grams of propane, this is propane, C3H8, produces 25.2. Well, I really don't like the way that I wrote that. I want this to be in, think about the way that we want this to be. We want molar heat of combustion, so we want this in kilojoules per mole. So I want the moles on bottom, the mole slash mass value. I want the kilojoules on top. So 25.2 kilojoules on top, the 0.500 grams of the C3H8 on bottom. That's going to give us a kilojoules per gram of C3H8, but I want that as kilojoules per mole. That's why it was important up here for me to pay attention to my units. And you notice what happened. I had it backwards until I thought about what my units were supposed to be in the end, and I flipped it. Anybody, even if they've been teaching for 32 years, can make that kind of mistake if you don't pay attention to your units. So we've got kilojoules per gram right now, and I want it to be in moles, so I look up the molar mass of C3H8, add that up, and get 44.11 grams of C3H8 per mole. And when I multiply that out, I get negative 2,220 kilojoules per mole for this particular reaction.